Okay, fine. Today we'll talk about Maxwell's equation and how to write the Maxwell equations and how to set up an equation or how to determine whether this relationship holds or not. Let's start with auxiliary functions. This chapter is dedicated to auxiliary functions. Okay, so this chapter is for auxiliary functions, and we'll talk about one important relationship. That is, if we'll talk about how it is set up. Is z if z is a function of x and y, then dz can always be written as del z del x at constant y into dx plus del z del y at constant x in dy. Okay, so this is the basic property. Now if del z del x at constant y is still a function of del z del x at constant y is still a function of another variable. It's a function of x and y, so let's say L of x y, and if del z del y at constant x, let's say a function of m of x y. Okay, if del z del x is a function of x y and del z del y at constant x is a function of another x y is another function of x y, then then we can always then dz can be written as L dx plus m dy. Okay, dz can be written as L dx and m dy. So a lot of thermodynamic functions are expressed in this way, so we'll see what it is. So now the important condition, if this also holds true, if this can be written, and if z is a state function, do remember this, that is, then the change, the differentiation or the double differentiation is independent of the order of differentiation. Okay, z is independent, change in z is independent of the order of differentiation. So we write del del y of del z del x at constant y and this at constant x is equal to can be written as del del x of del z del y at constant x constant y. If this is true, then finally we can write the most important relationship, that is del L, this L, del L at del y at constant x is equal to del N del x at constant y. This is the most important relationship. Just to remember, this is a very important relationship. So if dz is L dx plus m dy, then del N del y at constant x is equal to dm dx at constant y. So you'll see how this is important for all the thermodynamic important relationship and functions. So we'll start with the main parameters, so the main auxiliary functions to operate. We have started excuse me, with all this talking about internal energy. As I have always written, is T ds minus PdV, right? TdS minus PdV, better energy. So if you just see this, see this expression and compare it with del Z is equal to LdX plus MdY, okay? Compare it with this one, right? So what we can write from this, we can always write that del T, del T del V, del T del V at constant S is equal to, there's a minus sign, so you incorporate here or here, doesn't matter. So there will be a minus sign of del P del S at constant dm dx. So you just write this analogy, del L del Y at constant x is equal to del M del X at constant Y, so at constant V, right? So this is the relationship we can directly write. How to obtain this? You just remember d equal to TdS minus PdV. If you just then apply the Maxwell's equation, or you just apply the rules of differentiation, you will end up with this equation. This is the first Maxwell equation. So this is the equation number 1. So these are the first Maxwell equation. Let's write Maxwell's equations. Right, Maxwell's equation. This is the first equation. So let's take another example. So it's the internal energy. Sometimes you are asked this, right? So let's take another example. Let's take the enthalpy. dH is equal to TdS, right? TdS plus VdP. Right, dH equal to TdS plus VdP. So I hope you remember how this equations has been derived. H equal to U plus PV. So if you're just wondering how this equation is established, how this relationship is established, I just want you to remember this: H equal to U plus PV. So you take dH is du plus PdV plus VdP. So just evaporating du is nothing but TdS minus PdV. So your PdV cancels out, so you're left with TdS plus VdP, right? So this is the final expression. Okay, fine. Right? So let's see how to establish the Maxwell's equation in case of enthalpy. So again, it's very simple, right? Now del T, del P, now del T, del P. So dl dx at constant y, L dx. So this is L dx and M dy. So you always write del L del y at constant x. Constant x means here is S is equal to del V del S at constant P, del M del X at constant Y, right? So this is your second Maxwell equation. Del T del P at constant S is equal to del V del S at constant P. So this is the equation number 2. This is the second Maxwell's equation, right? This is from the enthalpy relationship. Right. Let's go. Let's take another one. Let's take the third one. Let's take the free energy equation. dG is equal to, right, minus S dt plus VdP. Right. dG is equal to minus S dt plus VdP. This minus is visible. Yes, now it is visible. Minus STD plus BDB. So if I again apply the Maxwell's rule, LDX plus MDY, so how it will be? Here L is minus S, so I can just write del S or del P at constant T is minus del V del T constant P. So this is the third equation. That's the third Maxwell's equation, right? The third Maxwell's equation. What is the final Maxwell equation? It comes from another auxiliary functions, which is we call it a Helmholtz function. We'll talk about the derivation of Helmholtz equation, but before going into that, we just write the Helmholtz function denoted by A. So it is written as dA is equal to minus SDT, minus PdV. So both here is minus, so it will ultimately cancel out. So I just write del S del V at constant T equal to del P del T constant V. Del S del V at constant T is equal to del P del T at constant V. Now these equations are sometimes given as multiple choice questions, and you have to select which of the relationships are true, including the minus sign, the order and everything. So if you just are wondering how do you remember, so you basically need to remember these four equations. That is, D is equal to TdS minus PdV, dH is equal to, right, TdS plus PD minus PdV, TdS plus PdV, dG equal to minus SDT plus PdV, and dA equal to U plus TS basically minus SDT minus PdV. So this relationship you have to remember. In case you are wondering, if you don't want to mark this relationship, then I'm giving you a cheat sheet, which will be very similar to a kind. Just follow this logic. You have to remember only one equation. All the equation will come from them. The equation you need to remember is del Q minus del W, which is the first law of thermodynamics. Nothing to remember, right? H you have to remember, U plus PB, which has nothing to do with any relationship. And G you have to remember, H minus TS. If you just remember these three, everything follows from here. Let's see how. So so del Q is, we have written that del Q, the Q del Q is nothing but, del S ds is nothing but del Q by T. So del Q is basically TdS. So if I write about du, okay, which is a du, right? Sorry, this is du. So du is nothing but TdS, and the expression of work is always given by PdV. So TdS minus PdV, your first equation. You get your first equation. You don't need to remember it. This is the second law, which is the expression of entropy, and this is the first law. Combining this, you get the first relationship for Maxwell equation. Similarly, if you just remember H is equal to U plus PV, so you write dH is equal to du plus PdV plus VdP. I'm taking complete differential. Now if you just see here, du is TdS minus PdV, so you just cancel out. So you're left off with TdS plus PdV, right? TdS plus PdV. This is the equation plus dH. From here you get the second Maxwell equation. This is so simple. No? You just follow this logic. H is equal to U plus PV. and this is the first law of thermodynamics. This is the second law of thermodynamics. You combine this two and you get everything. Let's do it for the free energy. So your dg becomes dH minus TdS minus S dt. So if you just substitute this dH, so your TdS will cancel out, right? So you will be left up with dg equal to minus S dt plus B dV. The fourth Maxwell's equation, right? And A is similarly, you do it for yourself, U minus TS. So you substitute that and you get your expressions. The fourth Maxwell equation follows from here. The third, this one is the first. So many times, the guest questions are being asked from this. They just put up a relationship and they just ask which of this relationship holds true, or which, or they give multiple, relationships, and they ask that, which one of these are true, or which ones are true. They can ask different questions. So if you follow this simple logic, how this follows from the central concept of internal energy and enthalpy, you can deduce all the relationship, all the subsequent relationship for yourself. Okay, fine. Thank you for watching this video.